Hi everyone, welcome to my channel. Today we are very exciting about this GraalVM topic because it is a very interesting topic and it is a very interesting piece of engineering that is from Oracle Labs. So we will be doing a high performance Java applications with native compilations targeting either Linux, Windows, Macs, whatever platform you are targeting. Let's get started. So if you are in a microservice world and you want to develop an applications for cloud natives like AWS functions or either microservices, and you want a high performance with scale down and scale ups and it starts very quick and memory doesn't take too much, this is the piece of engineering that you need to look. Now GraalVM is natively developed in Java, so its whole applications has been developed in Java. It is another virtual machines that has been done by GraalVM team from Oracle Labs. So I will show you the comparison between an applications running without a GraalVM and applications after running with integration with native compilation with GraalVM. So there are many different languages supported over here. So we will be using Java because GraalVM is natively supports and very well for Java. So just I have this applications, the whole applications that has integration testing. So let's run the integration testing first. So it has MongoDB with all Swagger implementations, all those APIs. So there are total 101 test cases, which is using a test container to run all these applications. And it has CRUD operations of MongoDB with lots of business logics in here. So let's run this application without a compilations. First I will run these applications using the IDE. So for that I will just run this one. So now if you see in the IDE over here, it takes an time of millisecond 1034 millisecond to start an application. Now this is Micronaut applications. Micronaut itself, it's very fast and doesn't consume lots of memory. But let's say if I am stopping again, this is running against the IDE. So I will show you this one with an IDE. Again, it takes 1061 milliseconds. It's almost 1061. So now let's run this one with Gradle. Just we will do Gradle w run for this one. So if we run an applications over here and if we check the server startup time is 891 milliseconds. So something little best than compared to the IDE. Let's run again. So if we check, it's almost 871 milliseconds, which is 200 milliseconds less than the running in the IDE. Now just imagine I'm just recording this video and sharing my screen. So due to this also that might has been increased some of the milliseconds over here. So just to make sure, so I'll just run it again. So if I run it again, so it starts in 891 milliseconds. It's almost the same. So now let's see, we will run these applications in native compilation mode. Now I am using a Mac, so this native compilations will be bring an executable file that will run only on Mac. But this native compilations is not like you can build in one application and run in different environments. But this is for specifically targeting for each platforms. Like if you are Linux, that will be native compilation for Linux, and if you are using Mac, it will be Mac. For the native compilations, you have to do Gradle w native compile. This is another already inbuilt functions in the Micronaut framework because Micronaut and GraalVM is match Mac in the heaven, so it gives you all the benefits. So if we compile this one, this will do a static analysis, all those build time, everything, because I have already compiled the applications before this video, so it just takes the catch and do everything. Now if we do compile this native compilation and if we go to the IDE the native compilations will be inside build. If you check here, native and native compile, which has this Fetty per product natives. So I'm just gonna execute this one. I'm just gonna go to that path and I will execute this one. So it will be API, then it will be build native build, and so we are just inside the native compilations directory. So if I do ls, I can see a Fetty per product native. This is the compilation. So just I will use Fetty per native. Now it runs the same applications. Now over here, if we check the startup time for this one, see, we found it. It starts in 37 milliseconds. So it was almost in the IDE. If we go to IDE, in the IDE it was 1061 millisecond, and if just before that I was running with GraalVM build and it was almost 891 millisecond. Now with the native compilation we can see it starts in 37 millisecond. I will stop this one and start this one again. So again, if you see it 33 milliseconds. So it came from 800 to 33, which is very fast, right? So if I check how much memory it consumes, so I'm just using active monitor over here, activity monitor on the Mac. So if I just search my applications, see this whole application is using MongoDB, CRUD applications with micro streams, all those integration testing with Docker. It's only contain 43.6, it became now 47.6 MB. That whole application is only 47.6. So this Micronaut with GraalVM is very well for serverless applications and microservice applications. Please have a look on this piece of engineering. It's very good and it's going on very well for the future as well. So Java will be more on the server sides by this, because it's giving you the same performance as the Go languages. So if you see without a compilations, you were 1031 something in the IDE, and on the terminal with the GraalVM it was 800. Now with native compilations it's with this one. It's very fast and memory consumption is very low. Thank you for watching my video and keep subscribing to my channel.